Welcome back, guys. This is going to be day 5 on arithmetic series. Day 4 was talking about arithmetic sequences, lists of numbers. Series just means we're going to take that list, we're going to add each of those components there. Okay, so let's take a look at the first one here. Hardest part is interpreting what on earth this guy means here. So let's try it out. Over here, we're trying to find the sum of this series here. We're just adding all the terms in the sequence. So the sequence normally would be -1, comma 3, comma 7, dot, 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 all the way up to 54. Problem is we don't know how many numbers there are. We don't know what n is. We need to solve for that. We also need to find the sum. So first rule of order here is to find what n is. Then we'll figure out the sum. But for now, let's just at least get the formulas going here. We got, what is that? The first term is -1. Last term is going to be 54. Oh, actually, this is a mistake. This should be 55. Tried this before, and this was wrong because it wouldn't give us a nice number, so it's going to be 55. Cool. So we can't solve this because we got too many variables. We don't know the sum of all the numbers because that's eventually what we want to know. But we also don't know is how many terms there are. 55, is it the 8th term? Is it the 15th term? And no, you're not going to sit there and count. You can do it if you want to, just to check, but we're not going to because we got better things to do with our time. So instead, what we're going to use is the previous formula that we used on the last notes. It's the sequence formula for arithmetic sequences. Can we find D, the difference? Easily. Look at this. Look at the formula here. From -1 to +3, I just add 4. From 3 to 7, add 4. Now, last time I did say don't do it that way. You want to think of it as like from the second term to the first term. How much am I sort of getting the difference of it? 7 minus 3 is 4. 3 minus -1 is 4. So we can plug that in. That's going to be 4. We know A sub n. A sub n is referring to which term, the nth term of the sequence. We know the nth term. It's 55. We just don't know what n is. And we know the first term because that's given to us, -1. And now take a look here. We got one variable to solve for, that's n, starting with that. So we're going to add 1. We get 56 equals this. Whoops. Divide by 4. So that's going to be, I believe, 19. Let me just think about that real quick. 2 times 4, I shouldn't. Mr. Bright can't math, it's 14. Add 1, so we get n is equal to 15. So now we can go back over onto the left-hand side. The sum of the first 15 numbers is 15 over 2 times 54. And that should produce for you the answer at the very end. So we're going to have to use the previous stuff on sequences to help us figure out what we need for the series. So we're going to use the two in conjunction. Heads up, my camera might die in a few minutes here because it's overheating, so just bear with me if there's no talking head. I don't know if you guys even care about the talking head in the first place, but anyways. All right, new notation, yay. Calculus is gonna be even worse than this, worse, I can't talk English. All right, let's start with the summation notation here. It's gonna be sigma, or a big E, depending on what's your cup of tea there. Basically what you're doing is, this is the sequence that is provided for you. The summation formula, that big E, is saying add up everything in that sequence. So you're going to start from what we call the lower bound, k equals 1. It could be a equals 1, n equals 1, it doesn't matter. It's just some variable, all the way up to the upper bound. So let me just do an example, just it's easier that way. Here, lower bound is 1, upper bound is 5. Typically, you would normally see this as, on the bottom, k equals 1. It usually tells you which variable, because sometimes you might have more than one. So here's how we translate it. You plug 1 in, you get, what is that going to be, 8. And then you iterate 1 to 2. It now becomes k equals 2. So plug in k equals 2. You get 10 plus, that's 13. And we're adding it as we go. We already did k plus 2, or k equals 2. Now we increase to k equals 3. Plus sign here. K equals 3. 5 times 3 is 15, plus 3, 18. Hopefully you get the gist here. This provides for us what the sequence is. The sigma notation tells us we're going to add things in the sequence. And the lower bound and upper bound tells us how far in the sequence we're going to go. We're going from the first term to the 5th term. Over in letter B, you can change the lower bound and change the upper bound as you see fit. You can have more than one variable. This should really just be k equals 2. But anyways, that's the idea. Now, a little trick I'm going to show you guys. Again, only use this for checking. Do not use this when you're taking the exit ticket because it's going to hurt you in the end. So let me show you how you can use this with a calculator, i.e. using Desmos. Now, you'll just change this to desktop here so you don't see me because it's just going to block my face. All right, if you go to Desmos, you can actually do this. Let's go ahead and full screen that. If you type in, if I got this correct, I believe it's sum. Yeah. If you just type in SUM, let me try again. SUM. You'll notice that it'll immediately create the sigma notation, and it defaults to n. N is usually sort of like the default variable it goes with. Let's pick the lower bound. Let's just say 1, usually. If you hit the up arrow, it skips you to the top. Down arrow goes back down. Up arrow, down arrow. Okay, so up here, let's just say it's like 5, and then over here, I'm going to say something like n plus 2. It does it for you. You can also use a TI-84 or 83 calculator. I would say go ahead on YouTube and try that out. It's pretty obsolete at this point, but it is a way that you can go about doing it. So just wanted to find you guys a nice little tutorial for this part here. And if you ever want to go back and be like, oh, I want to fix the top part, you can use your arrow keys. From this center part, you can go up by clicking the up arrow, right to go back to the sequence here, and then down arrow to go to the very bottom. Pretty cool, pretty nifty. All right, let's go back because that's not the point. All right, let's keep going. Hardest part now is problem solving. We're going to do the last problem, see how far we get. And let's turn that webcam back on again. There we go. And it's still running, cool. All right, this one's probably going to be the easiest by drawing it out. So let's try that. Object with negligible air resistance. So physics folks, we're going to ignore air resistance here, or air resistance. During the first second of the fall, so if you take an object, right, during the first second of the fall, we're just going to assume it's falling straight down. Object falls 4.9 meters. That's within the first second. Let's change colors. During the second second, so between the first second and the second second, it drops 14.7 meters. Probably should label it because I call you guys out for that all the time. If I don't do it, that makes me a hypocrite. On the third second, this is going to be dropping 24.5 meters. Okay, this is an actual real life thing here. Just a heads up. So we're going to say this is kind of like between 0 seconds and 1 second. This is going to be between the 1 second mark and the 2 second mark, and so on and so forth. Or, if it helps you even better, this is the point where 1 second has passed. This is the point where 2 seconds have passed. This is the point where 3 seconds have passed. Maybe see a sequence of some sort here? Let's try it out. So, we're trying to find how far it's going to fall in 10 seconds. So we know that that means n is 10. And so we are told it's arithmetic, so we can use this formula. All right, so n is 10. We know that. Let me just write here again, just for redundancy. Do we know what the difference is? And that's pretty straightforward. Can you find a difference between each of the terms? So, difference between these two terms here. That is going to be, if Mr. Perk can do it without a calculator, because, you know, he should be able to. That should be 9.8. Yay. Difference between these two should also be 9.8. Perfect. Yeah, there we go. Nice. So difference is 9.8. And I think we're all set to go. And we know the first term, a sub 1 is going to be 4.9. That's provided for us. So let's plug it in. A sub n, in this case we want 10, equals 4.9 plus 10 minus 1 times the 9.8. Again, hardest part about this entire word problem was first reading through it and then interpreting what you needed. Drawing will help sometimes. Logicking out will also be very helpful, as is critical thinking, as I tell you guys all the time. But once you see everything kind of like a puzzle, once it matches together, you should be able to solve what the problem is really asking you for. Again, hardest part, most likely, aside from the interpretation and all that stuff, is really understanding what a sub n means. I think a lot of you guys are going to have a hard time at the beginning here, just wrapping your mind. A sub n just means, oh, it's like the nth term. So if it was a sub 2, it's the second term. A sub 500, it's the 500th term. Talk yourself through it, externalize or internalize, whatever works for you, and use that to your advantage. Because I think in the previous day 4 stuff, I was talking about like a sub n like real quickly, and I think some of you guys are probably confused about that. So again, break it down. What does a sub n really mean? What does a sub 1 mean? What does a sub 2 mean? Break that down, go through the process, and find what you know, and then solve for what you don't. One quick thing I'm going to just harp on for the practice. I believe this is the one that has the problem I am speaking of. It's the one about the balance. Oh, nope, that's geometric. That's for another day. We're going to stop there, try the practice out, have fun with it.